Classical physics versus quantum physics. What's the difference? Physics has shaped how we understand the universe for centuries. But did you know that the world of classical physics is vastly different from the strange, fascinating universe of quantum physics? Today, we'll take a deep dive into the key differences between these two worlds and explore their impact on science, technology, and our everyday lives. Let's begin. What is classical physics? Classical physics forms the foundation of how we understand the world at the macroscopic level. Imagine an apple falling from a tree. Newton's laws of motion explain why it falls and how fast it hits the ground. Classical physics is rooted in principles like motion, gravity, energy, and light, developed by pioneers such as Newton, Maxwell, and Galileo. It's the science of the everyday world, predictable, measurable, and precise. Real-life examples of classical physics. Think about throwing a ball into the air. Classical physics can precisely calculate its trajectory, speed, and where it will land. Or consider a car driving on a straight road. Classical physics governs its motion, from acceleration to friction. Even the colors of a rainbow can be explained using classical theories of light refraction. These predictable laws are what allow us to design bridges, launch rockets, and even plan our daily routines. What is quantum physics? Now, let's shrink down to the atomic and subatomic scale. Quantum physics describes the bizarre behavior of particles like electrons, protons, and photons. At this scale, the rules of classical physics no longer apply. Particles can exist in two places at once, behave like both particles and waves, and follow probabilities rather than certainties. This strange world was uncovered by scientists like Max Planck, Albert Einstein, and Niels Bohr, and it continues to challenge our understanding of reality. Real-life examples of quantum physics. Quantum physics isn't just theoretical, it's powering some of the most cutting-edge technologies today. Quantum computers, for example, use superposition and entanglement to solve problems far beyond the capabilities of classical computers. Fiber-optic communication systems rely on quantum principles for secure data transfer. Even medical technologies like MRI scans are built on quantum mechanics. The microscopic quantum world is shaping the macroscopic technologies of the future. Key differences. So, what's the difference between these two branches of physics? Classical physics is deterministic and applies to the macroscopic world. It tells us that if we know an object's current state, we can predict its future. Quantum physics, on the other hand, is probabilistic and governs the microscopic world. Here, uncertainty is a fundamental principle, and the behavior of particles can only be described in terms of probabilities. It's like comparing a ticking clock to rolling dice. One is predictable, while the other is uncertain. Mind-bending quantum facts. Here's a mind-blowing fact. The laws of quantum physics apply to everything in the universe, including you and me. However, at our scale, these effects are so tiny that they go unnoticed. In the quantum realm, particles can teleport, become entangled over vast distances, and even exist in multiple states simultaneously. These phenomena aren't just theoretical. They're being observed and harnessed in labs around the world. Why do these fields matter? Both classical and quantum physics are vital to our understanding of the universe. Classical physics gave us the tools to explore space, build skyscrapers, and master energy. Quantum physics is pushing the boundaries of what's possible, from quantum computing to teleportation. Together, these two fields form the backbone of modern science and technology, driving innovation and discovery. Closing thoughts. So, which do you find more fascinating, classical physics or quantum physics? Both are incredible in their own right, shaping the world we live in and the technologies of the future. Let us know your thoughts in the comments below. And if you enjoyed this journey into the world of physics, don't forget to like, share, and subscribe for more exciting science content. Until next time, keep exploring.